Hello all, welcome to Embedded Linux Learning Point, Linux from Scratch 11.0, Episode 7. In this episode, we will start from Part 3, Building the LFS Cross Toolchain and Temporary Tools. Important preliminary material. Introduction. This part is divided into 3 stages. First, building a cross compiler and its associated libraries. Second, use this cross toolchain to build several utilities in a way that isolates them from the host distribution. Third, enter the chroot environment, which further improves host isolation, and build the remaining tools needed to build the final system. So one important note here, with this part begins the real work of building a new system. It requires much care in ensuring that the instructions are followed exactly as the book shows them. You should try to understand what they do, and whatever you whatever your eagerness to finish your build, you should refrain from blindly type them as shown, but rather read documentation when there is something you do not understand. Also, keep track of your typing and the output of commands by sending them to a file using the T utility. This allows for better diagnosing if something gets wrong. So even this is the purpose of this series, that we try to build the Linux from scratch. Also, one we would like to understand what each steps or commands does, plus what each modules that we build are going to do. So that's basically the primary aim of building this LFS. The next section gives a technical introduction to the build process, while the following one contains very important general instructions. Okay, so the next section gives some important general instructions about the tool chain and and the cross compilation method and things like that. Tool chain technical notes. Okay, this section explains some of the rationale and technical details behind the overall build method. It is not essential to immediately understand everything in this section. Most of this information will be clearer after performing an actual build. This section can be referred to at any time during the process. The overall goal of chapter 5, that means the next chapter, and chapter 6 is to produce a temporary area that contains a known good set of tools that can be isolated from the host system. By using chroot, the commands in the remaining chapters will be contained within that environment, ensuring a clean, trouble-free build of the target LFS system. The build process has been designed to minimize the risks for new readers and to provide the most educational value at the same time. The build process is based on the process of cross compilation. Cross compilation is normally used for building a compiler and its toolchain for a machine different from the one that is used for the build. This is not strictly needed for LFS, since the machine where the new system will run is the same as the one used for the build. But cross compilation has the great advantage that anything that is cross compiled cannot depend on the host environment. So cross compilation is something very important for let's say embedded systems. So when you're building Linux for embedded system, we have to do cross compilation. That's because uh, the target system will not have the resources that is needed for the build. So that's the reason we go for cross compilation. Maybe in this section, it gives we dig a little deeper into what is cross compilation and how do we do it. At least we understand the theory of it. Um, in the future series, we will touch upon cross compiling for, let's say, BeagleBone or any other uh, embedded, or I would say the controller or processor which is specifically needed for embedded systems. So in the current case, the architecture is x86 and 64. If let's say if you want to build for ARM architecture, we have to do cross compilation. So we'll understand more in the coming series. Okay, about cross compilation. The LFS cannot. The LFS book is not and does not contain a general tutorial to build a cross or native toolchain. Don't use the commands in the book for a cross toolchain, which will be used for some purpose other than building LFS, unless you really understand what you're doing. Cross compilation involves some concepts that deserve a section on their own. Although this section may be omitted at first reading, coming back to it later will be beneficial to your full understanding of the process. Let us first define some terms used in the context. This context. Build. Build is the machine where we build the programs. Note that this machine is referred to as host in other sections. Host is the machine or a system where the built program will run. Note that this use of host is not same as in other sections. Target is only used for compilers. It is the machine the compiler produces code for. It may be different from both build and host. Okay, so in our example, build is the machine where we build programs. Uh, okay, so in our context, it is the PC that what we are doing here. This is the build and the host. The target is something like for which we are going to build the code for. Okay, here he gives an example. As an example, let us imagine the following scenario. Sometimes referred to as a Cambian cross. Okay, we may have a compiler on a slow machine only. Let's call it a machine A, and the compiler CAA. So CAA is the machine compiler on a machine A. We may have also have a fast machine B, but with no compiler, and we may want to produce code for another slow machine C. To build a compiler for machine C, we would have three stages. Okay, stage one: build, host, target, and action. Okay, in the first stage, what we have to do is build cross compiler CC1 using CCA on machine A. Okay, so in this case, the build and the host is the same machine. Okay, and in the second stage, build cross compiler CC2 using CC1 on machine A. So in this case, machine A is a build and B is the host. The target is C. And third stage is build compiler CC using CC2 on machine B. So here the build is B, machine is B, host is becomes C, the target is C. Then, okay, I hope it's a little bit clear. Then all the other programs needed by machine C can be compiled using C2 on the fast machine B. Note that unless B can run programs produced for C, there is no way to test the build programs until machine C itself is running. For example, for testing CC, we may want to add a fourth stage. Stage 4, build is C, host is C, the target is C. Rebuild and test CC using itself on machine C. In the example above, only CC1 and CC2 are cross compilers. That is, They produce code for a machine different from the one they run on. The other compiler, CCA and CCC, produce code for the machine they run on. Such compilers are called native compilers. So in this case, the first, the build and the host, let's say CCA is a native compiler, and the third stage where the host and the target are again again C. That means the CC is a native compiler. I mean CC2 is a native compiler. So implementation of cross compilation for LFS. Okay, so this is a general idea of what is cross compilation. This is the specific case what we will be doing in this book. In order to fake a cross compilation in LFS, the name of the host triplet is slightly adjusted by changing the vendor field in the LFS TGT variable. We also use use the hyphen hyphen with sysroot option when building the cross linker and cross compiler to tell them where to find the needed host files. This ensures that none of the other programs built in Chapter 6 can link to libraries on the build machine. Only two stages are mandatory and one more for test. So here, build host, okay, in the first stage, PC, and LFS. So for us, LFS is the target. The build and the host is the same PC that we will be using. Build cross compiler CC1 using CCPC on the PC. Okay. In the second stage, a PC is the build, host becomes the LFS, and the target is also an LFS. Build compiler CCLFS using compiler 1 on the PC. In the third stage, LFS is the build, host is again LFS, target is LFS. Rebuild and test CCLFS using itself on LFS. Okay, in the above table, on PC means the commands that are run on a machine using the already installed distribution. In our case, uh, whatever the distribution that we use here, this is the uh, PC. On LFS means the command that are run in a ch rooted environment. So that comes later. Now there is more about cross compiling. The C language is not just a compiler but also defines a standard library. In this book, the GNU C library named glibc is used. This library must be compiled for the LFS machine, that is, using the cross compiler CC1, but the compiler itself uses an internal library implementing complex instructions not available in the assembler instruction set. This internal library is named glibgcc and must be linked to the glibc library to be fully functional. Furthermore, the standard library for C++, libstdc++, also needs being linked to the glibc. The solution to this chicken and egg problem is to first build a degraded CC1 based glibc lacking some functionality such as threads and exception handling, then build the glibc using the degraded compiler. glibc itself is not degraded. Then build libstdc++, but this last library will lack same functionalities as glibc. This is not the end of the story. The conclusion of the preceding paragraph is that CC1 is unable to build a fully functional libstdc++, but this is the only compiler available for building C++ libraries during stage 2. Of course, the compiler built during stage 2, CC/LFS, would be able to build those libraries, but one, build the build system of GCC does not know what that is usable on the PC on a PC, and two, using it on PC would be at risk of linking the PC libraries since CCLFS is a native compiler. So we have to build libstd++ later in chroot. Other procedural details. The cross compiler will be installed in a separate LFS tools directory since it will not be part of the final system. Bunutils is installed first because the configure runs of both GCC and glibc perform various feature tests on the assembler and linker to determine which software features to enable or disable. This is more important than one might first realize. An incorrectly configured GCC or glibc can result in a subtly broken toolchain, where the impact of such breakage might not show up until near the end of the build of an entire distribution. A test suite failure will usually highlight this error before too much additional work is performed. Bunutils installs its assembler and linker in two locations, LFS tools bin and LFS tools LFS DGT bin. The tools in one location are hard linked to other. An important facet of the linker is its library search order. Detailed information can be obtained from LD by passing it the verbose flag. For example, LFS TGT LD -verbose grep search will illustrate the current search path and their order. It shows which files are linked by LD by compiling a dummy program and passing the -verbose switch to the linker. For example, LFS TGT GCC dummy.c -wl -verbose, you're redirecting both error and the standard output and the error. Grep succeed will show all the files successfully opened during the linking. The next package installed is GCC. An example of what can be seen during its run of configuration is checking what assembler to use. Mount LFS tools, it uses this one, assembler. Checking what linker to use. Mount MNT LFS tools i8686 LFS Linux GNU bin LD. This is the linker. This is important for the reasons mentioned above. It also demonstrates that GCC's configure script does not search the path directories to find which tools to use. However, during the actual operation of GCC itself, the same search paths are not necessarily used. To find out which standards linker GCC will use, run lfstgtgcc print program name ld. Let me just try and see what it shows. Okay, so command is not because we have not reached the stage yet where we have the CC1 compiler. Okay, detailed information can be obtained from CC by passing the -v command line option where while the compiling a dummy program, for example gcc dummy.c, will show detailed information about preprocessor compilation and assembly stages, including GCC's included search path and their order. Next installed are sanitized Linux API headers. These allow the standard C library glibc to interface with features that the Linux kernel will provide. The next package installed is glibc. The most important consideration for building glibc are the compiler, binary tools, and the kernel headers. The compiler is generally not an issue since glibc will always use the compiler relating to the "-host parameter passed to its configure script. Example, in our case, the compiler will be LFS GCC. The binary tool and the kernel headers can be a bit more complicated. Therefore, we take no risks and use the available configure switches to ensure to enforce the correct selections. After the run of configure, check the contents of the config.make file in the build directory for all important details. Note that cc compiler flag LFS TGT with LFS TGT expanded to control which binary tools are used and use the no stdinc and -i system flags to control the compilers include such path. These items highlight an important aspect of the glibc package. It's very self-sufficient in terms of its build machinery and generally does not rely on toolchain defaults. As said above, the standard C++ library is compiled next, followed in chapter 6 by all the programs that need themselves to be built. The install step of all these packages use the testdir variable to have the programs land into the LFS system. At the end of chapter 6, the native LFS compiler is installed. The first binutils pass2 is built with the same the destination directory install as the other programs. Then the second pass of GCC is constructed, omitting libstdc++ and other non-important libraries. Due to some weird logic in GCC's config script, CC for target ends up as CC when the host is in the same as the target, but is different from the build system. This is why CC for target equal to $LFS-DGT-GCC is put explicitly into the configure options. Upon entering the chroot environment in chapter 7, the first task is to install libstdc++, then temporarily and then temporary installations of programs needed for the proper operation of the tool chains are performed. For this point onwards, the core toolchain is self-contained and self-hosted. In Chapter 8, final version of all the packages needed for a fully functional system are built, tested, and installed. Okay, so here in this section, it's more of how are we going to do a cross compilation for LFS. So that's the overall idea here. General compilation instructions. When building packages, that there are several assumptions made within the instructions. Several of the packages are patched before compilation, but only when the patch is needed to circumvent a problem. A patch is often needed in both this and the following chapters, but sometimes in only one location. Therefore, do not be concerned if instructions for a downloaded patch seem to be missing. Warning messages about offset or fuzz may also be encountered when applying a patch. Do not worry about these warnings, as the patch was still successfully copied. During the compilation of most packages, there will be several warnings that scroll by the screen. These are normal and can safely be ignored. These warnings are, as they appear, warnings about deprecated but not invalid use of C or C++ syntax, These standards change fairly often, and some packages still use the older standard. This is not a problem, but does not prompt the warning. Sorry, but does prompt the warning. Check one last time that LFS environment variable is set up properly. So this is something very important. Okay, it's perfect. Make sure that the output shows the path of the LFS positions mount point, which is mount LFS using our example. Finally, two important items must be emphasized. Okay, the instructions assume that the host system requirements, including symbolic links, have been set properly. Bash the Selenium news as such is a symbolic link to bash, user AK symbolic link to JWK, user bin YACC is a symbolic link to Bison or small script that executes Bison. Okay, so this is that we had done in the earlier sessions. Please do please go through the earlier chapters for this because it's very important. To re-emphasize the build process, place all the sources and patches in a directory that will be accessible from the chroot environment such as mount LFS sources. Change to the source directory. For each package, use the tar program. Extract the package to be built. 5 and 6 ensure that you are the LFS user when extracting the package. So if you see, I am the LFS user when I extract the package. Change to the directory created when the package was extracted. Follow the book's instruction for building the package. Change back to the source directory. Delete the extracted source directory unless instructed otherwise. Okay, so these are some of the important instructions that we will be taking care when we are building the toolchain and when we're building the different uh, programs, I would say. Okay, so that's it for this episode. In the next episode, we will start building uh, for LFS, compiling the cross toolchain. So that's going to be from the next episode. That's it for now. Thanks for watching. Please do subscribe to our channel. Please do comment if you have any feedback or any suggestions. Thank you. Thanks for watching.